Okay, so today's lesson is 7.3. Should be fairly quick. So again, did anyone have any big issues from the homework last night? The only feedback I got was good. So any big problems?
I got a problem with the long numbers. I don't know how to do it.
What do you mean the long numbers?
Can you go it?
So
Here's your Sharpie.
I don't. Do you remember what number it was, Eminal?
I think number 7.
I can tell you.
Emerald, did I have a lot of numbers? I don't remember you. I think you was 7.
Like this?
Yeah.
Eminal, like this?
Yeah, that one. Yeah.
So.
I figured this one out. I looked at help me with solve this.
Yeah. All right. So what we should notice here is I have 8x, 7x, 14x, 32x, 13x, and 16x all being added together. What you need to ask yourself first is, are they like terms? What two things have to be the same to be like terms? Luke, give me one.
They have to be numbers.
Not necessarily. Oriana.
Oh, they have to have the same power.
Same power, but what is that power on? Brennan?
Variable?
The same variable. So these all have the same variable of x, and they all have the power of 1. So Emmanuel, all you have to do is add 8 plus 7 plus 14 plus 32 plus 13 plus 16. That sum x, because the x just comes along for the ride. Any other big issues? All right, so this is kind of convenient because now I can just jump straight over into the lesson. So if we want to write an expression to show the value of the items donated, well, do we exactly know what the value of a can of corn is? No, but we could assign a variable for it, right? So the first thing that we would want to do here to make our life easier is organize, right? Put these things so that we can see them easier. So I'm just going to start stacking my corn over here. I'm going to bring my money over to the right side of the table so we can see everything. My rice will go somewhere in the middle, I guess. My magic floating can of corn. So how could we write an expression to represent what we have up here? How would we start this if we just want to work left to right? Bunger, start me.
5C because there's 5 cans
5C, and we have, Luke?
2 boxes of rice.
2, so we could say R for that.
Is it 2 or 4? Because it looks like there's like...
No, that's just the top of it where you would rip it open. Karina?
3P for the P.
Plus 3P, plus, and then do we know the value of money?
Yes.
Yeah, so that works like a constant in this situation. So we've got 20, 40, 50, 55, 60, 65, $65.50. So that is how we could write an expression to represent what is going on up here. So we want to start, and actually I should pull your guys' notes up so I can work through at the same rate as you. We want to start by defining what it is to be a variable term, what it is to be a constant term, and what a coefficient is. So who thinks they have a good definition for what a variable term is? Eli? So it's a term that can vary, so it's something that we don't know, right? So we could say an unknown value which, how do we know that it's an unknown value? What, like mathematically, shows us that it's unknown? Cassidy?
There's no number because it's just a letter.
It's a letter. So we could say it's an unknown value which we represent with a letter.
I thought you said never to use, like, to call a variable a letter.
We have to represent it with a letter. So we don't call it a letter, we call it a variable, but we write it as a letter. Does that make sense? Yeah, good question. So, variable term is an unknown value which we represent with a letter. What is a constant term? Getting the same hands. Thomas?
A known value that has a letter right next to it.
Ah, it has no letter. I agree with you. It's a known value. But since it's a constant, it doesn't have a letter. We just have the number. So a known value, and you could say a number. It is just a number.
I meant to say that for coefficient.
Ah, so coefficient. What really does a coefficient do to your variable? If we have like 3x, well, what's that 3 really telling me? So what operation is it performing? Eli? Okay, again, Isaiah, what operation? Multiplication. So a coefficient is a multiplier to a variable term. A coefficient is a multiplier to a variable term. You could also say it normally comes in front of the letter, but sometimes it comes after, because you could have x times 5. Now the 5 then, there's an argument of whether the 5 is a coefficient, because technically that's not written in simplest form. In simplest form, we always put the number, the multiplier, in front of it. So you see down here, we have these defined on your notes for you. My coefficient here is -5, but also, and guys, there are questions like this on your homework. They're not trick questions. There is a coefficient in front of the y. It's just invisible. So we know there's actually a 1 there. So my coefficients here are -5 and 1. My variables are x and y. And I only have one constant term, it's the 2. But because I have an x term, a y term, and a constant term, there are 3 terms. So part of your homework, and the first couple of questions, there's going to be identify how many terms there are. That's easy. You just count how many different types of numbers or types of values that we see. Now, if I had multiple x values, I could combine those, so then there wouldn't actually be as many terms. But since I have an x, a y, and a constant, there are 3 terms. Any questions on that? Cool. So because we can always write a sum as a difference and a difference as a sum, this is good for you guys to see because we do this a lot. Instead of writing -a minus 2.5b, we can write -a plus a -2.5b, or vice versa. If you end up in a situation where you have plus a negative, I often rewrite it as minus because adding a negative is the same thing as subtracting. But the reason that we would want to rewrite this is to realize that your coefficient here is actually -2.5. Over here, it's still -2.5. It's just a little bit harder to see because a lot of you look at that as subtraction when it's both. It's subtraction or a negative value. And when we talk about the coefficient, we use it as a negative. Okay.
It says like the coefficient is -1. Wouldn't it be -1a?
No, because the a is the variable. The coefficient is only the number that is multiplying by the variable. So because we know there's actually a 1 out here, it's -1a. So my coefficient's -1. My coefficient to the b is -2.5. My variables here would be a and b, and there's no constant term. Cool? So try this table on your own. You want to take the expression, identify how many terms, what are any coefficients. Now, when we have multiple answers, we separate them with commas. So here, we'll do the first one together, then you guys are going to fly on your own. How many terms, and we'll start using cards here, how many terms do I have in this expression, Franny? 2, because I have a variable term and a constant term. We have 2 terms. What are my coefficients, or one coefficient? That's why the S is in parentheses. Isaiah, what's our coefficients there? For this expression, remember coefficients are the multiplier that comes before the letter or before the variable. For this expression, can you see from back there?
Yeah.
What number's in front of the A?
Oh, you're asking what?
So not how many coefficients, but what is the coefficient.
Okay.
Notice that's why this says number of terms. This doesn't say number of coefficients. It just says what is the coefficient or coefficients. Yeah, so that's 12 because 12 is my multiplier to the A. Bless you. And my constant, Layla, don't fall in the trap here. What's the constant? -3. Try the others on your own. Layla, did you get the notes that you had missed from being out?
Yeah.
Sweet. Did you get my email? The video? Sweet. I'm going to check the lesson and make sure I didn't skip anything. Sometimes it does not all fit on your notes.
The number.
Can there be more than
A term without a variable is a constant
Yeah,
term.
there can be more than one coefficient because they can
Because
be
you can
coefficients with
always
different
rewrite a difference.
values. So we went through all
As a
that. We are here. Making sure I have everything. Okay.
and they all have a coefficient.
All variable terms will always have a coefficient. If there's no coefficient shown, it's 1.
I know I meant like at least each of these have at least one coefficient.
If there's a variable, yes. So since each of those have variable terms, then yeah. All right, Brennan. How many terms in my second expression there? 3. Oriana, what are my coefficients in that expression?
0.2 and 8.1.
0.2, 8.1. What's in front of the y?
Negative.
A negative. It's invisible, but there's really a 1. So we also have -1. Do you need something, Mr. Beeler?
Yeah, do you have a lot of cups I could have?
Back, they may not be in great condition. If you just need cups. Party.
Remember that
I had these set up with like rubber bands and strings.
Alright.
Those are, you remember that?
Yeah.
A minute to win stuff.
Yeah. Thank you.
You're very welcome. Constants. Are there any constants in this term? Any in this expression? Any terms without variables? Nope. Now, so you could either put no, or mathematically, here's a new thing for you. What is the symbol? Some of you guys might know this. Used for the empty set. Thomas?
0.
You don't? Because 0, well, okay, so we could say 0 because we could say that there's a +0, which doesn't change anything. But mathematically, when there is not a result, you can put a 0 with a slash through it, and that represents the empty set. It means there are no constants. It doesn't exist.
That's what I do when I like that. My dad, when he's on like O's and zeros, hitting his zeros, he does that.
Yeah.
So it's more, so it's like obvious.
Yeah, because 0 is showing a lack of something.
And that's when there's no homework, that's what I do.
And my third one here is Bella sick?
Yeah.
I thought she was here in foundation. Maybe not. Bella, feel better. Hopefully you're watching the video. Abby, how many terms do I have in this third expression? Abby. We have this one, and that one, and that one. How many? Yeah, you're right. I'm not going to let you pass when I know you can figure out the right answer. Katie, what are my coefficients here? Ooh, is 7 on a variable? No, so since 7's not on a variable, 7 is actually our constant value. So then what are our coefficients? 9 and what? What is it? -6. So 9 and -6. Because we could rewrite this as 7 plus 9n plus, because actually, okay, so this gets kind of into the theory of math. There's no such thing as subtraction. There is adding a negative amount. There is adding, taking away of something. So subtraction is just what we've done to represent adding negatives, but this is adding -6mn, so that's why the -6 is actually your coefficient. We really, if you wanted to do math right, would put addition between all terms. And if it was a negative term, you would put the addition of the negative. But that looks a little messy, so we cleaned it up and decided to use subtraction. But there's really no such thing. There's also really no such thing as division. You're multiplying by fractions. So when you divide by 2, you're really multiplying by 1/2. Because the operations are inverses of each other. And my last one here, Eminal, how many terms? 1. You want to do the whole thing? What are my coefficients?
3/4.
What are my constants?
None.
There are none. Very good, sir. All right, got it on your own.
Oh, that's
Oh, that's at the bottom.
How many terms? List all the coefficients and list any constants. You can abbreviate coefficients by COEF. So you could say terms, not tems. Terms, coefficients, and then constants. You can abbreviate CON or CONST. But I'm just going to write out the whole thing. By the way, coefficient is a really fun word to spell. Coefficients. There's 2 I's in there. So if you're trying to spell it, pay attention. If you've ever spelled efficient before, like efficient means something's working well, it's just coefficient.
Oh, I forgot this.
So divine, how many terms do we have here? So we got a P term, a PC term, a C term, and then a constant term. So there's really 4 terms here.
Dang it.
Bela, there you are. You guys move around sometimes. Bela, what are my coefficients?
6, 7, and 9.
You're so close.
6, -7.
6, -7, and 9. Guys, that's where I see people get the most frustrated. They've been like doing a problem and did it over and over and over, and finally they come to me and they're like, why am I getting this wrong? And all I do is point to the minus. And they face palm and they walk away.
You always say that they face palm.
A lot. My class last year, for some, they liked doing that. They'd be like, just that sigh. And then constant term, Thomas. Do we have a constant term up here?
Yes.
What is it?
It's 4.
-4.
-4. I knew.
You're close. All right, moving on to the back of your notes.
I got those right.
So, we're out this play so that we can see it actively showing us. So the first thing you do when you go to simplify
Negative
expression
5
is
times
you look, and
x
this is
and
where
11
highlighters
times
are really
x
useful.
are
You
like
look for any
terms.
terms that are like, which again have to have same variable,
4
same power.
and negative
So we
9
see that
are
both
like
of
terms.
those terms have an x, and what power's on that x? If there's no power showing, power of 1. So we see that those both have x to 1, and then these both don't have a variable, so they're constant. Then we can rearrange, we can regroup. So I don't like this written out like this. My like terms are separated, they're far away from each other. Can I do what's in these parentheses? Can I do a negative 5x plus 4?
No.
No, why not?
Because
They're not like terms. So instead we regroup.
You can
so we
use the
see like
commutative
terms
and
put
associative
together.
properties of
So,
addition
since
to move
my
the terms
11 had
around
addition in
and
front of
group
it,
the like
now it's
terms.
just negative 5x plus 11x. Because my 4 was positive, now this is where people make their mistakes too. Your 9, you have to take that minus or the negative with it. So they say add the negative 9. Then I can combine the like terms. Negative 5x plus 11 will negative 5 plus 11.
To combine the like variable
positive
terms, use
to a
the
value
distributive
of
property
6.
to factor out the
And then
variable
4
part.
plus a negative 9. that
Then
actually takes a
simplify.
Negative to a value of negative
4.
5 actually. Remember, different signs, you find the difference. Different signs, you find the difference. So we get a positive 6x minus 5, or we could write this as positive 6x. How else could I write this? Instead of using minus, I could say, ooh, what Isaiah? Plus a negative. Boom. Yeah, I was going to say the same thing. You guys seem like nobody got sleep last night. My dog had me up between like 1:45 and 3 a.m. So, all right, on your own. On your own. Hey, ladies and gentlemen, on your own, try to complete these 3. Stick up a hand if you're having any issues. I will come by and help you. If you have a question that you think your neighbor can help you with, you might ask them what they got, but do not ask them just for the answer. Try and solve it on your own first.
Can we use a calculator?
No, you don't need one. These are all integer values. So, first step would be to rearrange, right? Work on your own. If you need help, glance up here. I'm not going to solve it all the way out. So we would rearrange to put the like terms together, or at least near each other. And then anything else. They're like ninjas. It's okay. Guys, they're going to be going around the whole school today, like different times on this little like scavenger hunt thing. So just when they come in your classes, just don't worry about it. So rearrange so your like terms are close to each other. Then do any of the addition or subtraction. Walk around, yeah, feel free. Yeah. Head on your desk, it's probably a little hard. It's easier to stay awake and alert. In case anyone is struggling, let's go to Cassidy. Do you have the answer to the first one? Yeah, you'll try. So we rearranged it because 2r and the negative 5r were like terms, so we put those together. What do you get when you do 2r plus a negative 5r? Or you could say 2r minus 5r. Yeah, so we get a negative 3r. I don't know why I changed color. Negative 3r. And then, was there a like term to combine with the constant? No. So it just stays plus 7. That's it. Keep working. This is when highlighters are pretty darn useful. No, it'd be negative 3r. And then plus 7, we can't combine those. They're not like terms. So your rearrangement in the second one they can't get the door shut. Or at least maybe they did now, but they had to try it like 5 times. Zach, do you have our answer for our second one?
You want me to tell you the answer right now?
Yeah, so what do you get when you combine the R's?
When you find out, you get negative 2r.
Yep, we get negative 2R.
And
Combine the constants.
you get 15.
Ooh. Remember, this had the minus in front of it, so it has to go with it. So it's really 4 plus a negative 11, or we could just say it's 4 minus 11. Yeah, it's going to take us negative. So then we get either plus a negative 7, bless you, or you could just write it as negative 2R minus 7. Either way is correct. But be careful, this constant value had the negative with it, so it has to go with it. That's another one of those common mistakes I see people make. You got the last one, Emil?
No, I just want to ask a question. Is it okay if we put parentheses or the
Yeah.
negative 2r?
So you could have totally... Oh, yeah, you don't have to since it's the first one, but you can. So you could put parentheses around this if you wanted. But also, like out here, you could say, okay, here's my R's that I'm combining, and there's my constants that I'm combining. So you could do that too if you wanted. Now, what did we need to do first? Mr. Bunger, your card is actually up now. What did we need to do first in this expression?
Put the like terms close to each other or near each other.
Not actually. Cassidy?
You have to do the distribute.
We have to distribute the 5 into the parentheses. So I have a feeling that some of you may have forgotten to do this. When there's a number right against the parentheses, we have to distribute. This really becomes then 5R plus 5, then plus negative 8R plus 2. Now we want to rearrange to put my R's close to each other. So we would have 5R minus 8R or plus a negative 8R because that negative goes with it. And then my constant values, I've got a 5 and a 2. When I combine these, 5R minus 8R takes me negative. We find the difference between them, and it's negative 3R plus 5 and 2? 7. Questions on any of these 3? Oriana? Does it matter what? Yeah. These are very similar to each other. Yeah, that's on purpose.
So in your homework, where you have to like put the answer, I put like 5R plus 5 plus.
You'll really probably most of the time be asked to put the answer in simplest form. So you would want to, like on your paper, do the work to rearrange them and everything. Guys, it really upsets me that as I walk around and I look at some people doing their math homework, that a lot of you try to do it without any pencil or paper. You're only hurting yourself. All you need is a sheet of paper out and a pencil to jot stuff down real quick. You can write things down as quick as you can think about them, and it helps you think about them when you write them down. So you really need to have paper and pencil out when you're doing your math homework. Which expressions are equivalent to negative 6 plus 5t? Now you can break this up and look for each one individually. I would start by saying which of these have a negative 6 when I combine the constants. Well, here I have 13 and 7. Would that give me negative 6? No, so I automatically know that 1 is out. Can't be it. Check my constants over here. This, what constant would that multiplication give me? Negative 10. Then plus a positive 4. That'll give me negative 6. Okay, we're good there. We'll leave 3. We'll come back to it. What about 9 minus 15? Would that give me negative 6? 9 minus 16? Or sorry, minus 15. And then negative 1 a positive 3, and then once I do this multiplication here, what's 2 times negative 3? Negative 6, right? So I have negative 6, positive 3, negative 1. Will that land me at negative 6? No. That would land me at like, yeah, negative, actually I think it'd be negative 4.
I'd be like negative 4.
So all we have left to work with is 2 and 3. Now look for the variable. We want 5t. Will I get 5t here? Yeah. So 3 checks out. It works. What about here? Will I get 5t?
Yes.
Yeah. So 2 checks out. It works. Both of these, number 2 and number 3, are acceptable.
I knew it. No, I didn't. I didn't know.
So that's another process you can take without rearranging everything. You can just look at each individual part. It'd be beneficial to write them down, especially if there's more than 2. But that's another route we can take. You're going to see a few of these problems on your homework too, where you have to write the expression based off a verbal situation. So a rectangular frame for a flower bed is 9 feet longer than it is wide. Do we know the width? Do we know the length? Do we actually? Can you tell me the length is blank feet?
It's longer, so you have to know width in order to.
So we can say here that the width, well, we don't know it, right? So we can just give it a letter, give it a W. It's a variable. But then to talk about the length, oop. Cassidy, what's it mean for something to be longer?
Well, it means that it's gonna be bigger, like longer than
Mm-hmm.
9 adding.
Ah, that's really what we were searching for. It's longer by addition. If you were going to try to use the 9 as a coefficient, it's not 9 times as long. It's just 9 feet longer. So this would be the width plus 9. We need to talk about the perimeter now. So the perimeter here, well, how do I find perimeter of a rectangle? Well, it's the length around it. Be careful saying area.
Length plus width.
So, as Emino just said, we've got 2 lengths and 2 widths. So, we have 2w is easiest to write first. I've got 2 widths plus 2 times the length, which is w plus 9. Because perimeter is 2w plus 2l. And this is now our L. So what do we need to do now, working towards simplifying? What operation needs to happen? Crystal, do you know? Thinking about, huh? Isaiah? We have to distribute because there's a number right up against our parentheses. So now, once we do that distribution, I get 2w plus, well, 2 times w. First distribution gives me 2w. 2 times 9? 18. What can I do now, Mr. Bunger? Add the like terms. 2w plus 2w gives me 4w plus 18, and that will be our perimeter. Try the got it on your own. I'll give you like a minute or two. Well, first off, any questions on the example before we jump to the got it? No preguntas? It means questions in Spanish. Preguntas. It's a very fun word to say because you can roll the R.
And you can see his friends too.
All right, No more rolling R's, or else all the principals walking around the school are going to think we have a room full of cats. So try to got it.
I love
Here's what you want to pay attention to. The length, we kind of know. The length is L. We've been told the length is L. And the width is 1/2 of the length. Again, we're looking for perimeter. The width is 1/2 of the length. So you'd want to start with what's the length, what's the width. I'm going to come over here so I have a bit more room. Give it about another minute. Make sure you distribute if you need to. Make sure you combine like terms at the end. You're not simplified if you haven't combined everything possible. Because for perimeter, you've got 2 lengths and 2 widths because they're identical. Yeah. Because really, if we walked around the shape, it'd be length plus width plus length plus width. But then we can rearrange and put the terms together. So we know the length is represented by L. But the width, we've been told, is 1/2 of the length. So, Divine, do you know how I can express the width using my variables? Eminal, if it's 1/2 the length, do you know how we can express it? Luke? Bela? Huh? Yeah, you can just do L divided by 2, or you could write 1/2 of L. It's 1/2 of the length of tells you to multiply. 1/2 of length. It has told you verbally what it is mathematically. Now we plug in. My width, I know, is 1/2 L. So when I do 2 times the width, well, the width is 1/2 of the length, plus 2 times the length, well, the length is just L. In case you're not familiar, this is cursive L. I will never use a non-cursive L. Why? It looks like a 1. Is that an L or a 1? Who knows? Because I don't like that either, because you end up using this symbol as angle, and a lot of people will look at this or make their L's and like their angle symbols are very, it's hard to tell which is which. So that's why we use the cursive L. Almost always you'll see L's by using the cursive lowercase l, because the cursive uppercase L is really sweet.
Oh, I love that.
Yeah.
Oh,
I always, just while we're on the note of cursive, I always liked making my last name. That's not even very good. So, Thomas. Now we have a number. Hey, give me 2 more minutes. We have a number right up against parentheses, Thomas, but do we have to distribute?
I actually said I got this answer a different way.
Okay.
So since L equals 2W, I turned the 2W into an L, and so then I added that, and now it's 3L.
Okay. So I was worried because I was about to highlight this in terms of L, but you still did that. So what Thomas just said is he realizes if W equals half L, then 1 whole L has to equal 2 W's. So this 2W must be L. The other way we can figure that out is 2 times 1/2. What's half of 2? 1. So this gives us L plus 2L. So my perimeter is really 3L. Questions, comments, concerns? We really want to practice this stuff, so your homework is 15 questions. I believe if you get 12 of them done, let me check that. Yeah, if you get 12 of them done, you're good. 12 out of the 15, you're good. That'd be 80%. So anything over 12, and you're really good.
I thought we had a master. I was get like 90 and above.
It's 80 and above is what it's been all year. All right, thank you guys. Have a great day. Yeah, dude, I love it.
Look, this is why I got